Okay, students, I am going to give an example to you. Let's take, this is an example for the Bayesian network. First, we have, as all of you know, we have the two components while working with that of the Bayesian network. One is the directed cyclic graph and second is the conditional table. And second is the conditional table. These are the two components which are very important while working with that of the Bayesian network. Here I am going to give one example. I'm going to make the directed acyclic graph, okay, which contain the one burglary, okay. Another, there is the component that is the earthquake. If both occur, alarm ring, okay. If alarm ring, there is one another node P1 calls and P2 calls. Let me explain you this example, then we will make the tables of this example, okay. This is the, there is the one person, like let's take there is a Jyoti, okay, or let's take the one is the Rahul, okay, and second is the Paras, okay. Rahul and Paras are two friends. Rahul, let me first P1, let's take the P1 as the Rahul and P2 as the Paras. P1 as the Rahul and P2 as the Paras, okay. And here we will take the one burglary probability and here we take the earthquake. Now the situation is like that. राहुल क्या है, राहुल और दोनों फ्रेंड्स हैं, ठीक है. राहुल ने क्या किया हुआ है, राहुल ने अलार्म लगाया हुआ है अपने घर पे. राहुल ने क्या किया हुआ है, अलार्म लगाया हुआ है अपने घर पे, ओके. और राहुल पारस को कह रहा है कि भाई अगर मेरे घर पे कोई भी चोरी होती है तो यू कॉल मी, चोरी होगी तो अलार्म बजेगा, तो मेरे को कॉल कर दी. इफ देयर इज चांसेस ऑफ द अर्थक्वेक आल्सो, अलार्म बजता है, तेरे को सुनाई देता है, तो मेरे को कॉल कर दी. देयर इज अ सिचुएशन, मींस देयर इज चांसेस ऑफ द burglary and there is chances of the earthquake. In both cases, if occurs, alarm rung, and if alarm, then P2 calls P1, like the situation is like this, okay. But always ये भी चांस नहीं है हमारे पास कि हमेशा P2 को सुनाई दे अलार्म, और ये भी चांस नहीं है कि there is a probability. Again, we are working with the probability concept. All of you know, as the Bayesian network work on the concept of the probability. So ये भी चांस नहीं है कि earthquake हो और अलार्म बजे ही बजे. That is also not the chance. और ये भी नहीं है कि चोरी हो तो फिर अलार्म बजेगा बेटा. That is also the probability. Means our algorithm totally works on the probability. There is a chances or not. Okay, this is our example. Now let's make the tables regarding these examples. Now I am going to make the table. First probability. First, I am going to make the table of this probability of the burglary. If the probability of burglary is true, means there is a possibility that is, let's take any value. That value you can take by yourself. That is the one thing. There is a probability, and there is probability that it false. Can be possible, cannot be possible. If not, let's take it. Okay, this is the one situation for this. Now let's take the probability for this case. This is the one table for the first part. Let's take the probability table for another earthquake. If earthquake true, take any value. Okay. And the probability of earthquake false, that is also, this is another table for first condition. Okay. Now, let's move to the another thing, that of the alarm. Now, when I work, there is the one is the B, burglary, and second is the earthquake. That means first condition can be, I'm going to make the possible entities. How many possible pairs can be there? Means both occur, that is one possibility. This occur, this doesn't occur, that is another possibility. This doesn't occur, this occur, that is another possibility. Both not occur, that is also possibility. Okay, that is also possibility. One thing, as we are working with the probability concept. Now, according to these conditions, our alarm will work. So if I want to find the probability of the alarm is equal to true, or probability of alarm is equal to false, what is that? Let's take another any value. Probability of true, if it is, that is 0. And it will be the 0.05. And remember this thing, the plus addition of both should be the 1. As the probability always work with the concept of the number 1. Means addition of 2 should be the 1. Okay. Again, next, there is chances of burglary, but not the earthquake. The alarm rung or not. If yes, then 0.99 or 0.01. That is another possibility. Let's take, if earthquake occur, alarm rung, can be probability. Not occur, that is another probability. Okay. Both not occur but alarm rung, that is another possibility. Means that can be also possible that no one, ना तो ये बगलरी हुई है, ना तो मेरा अर्थक्वेक हुआ है, बट किसी और की आवाज से भी मेरा अलार्म बज सकता है. That is also one possibility. Okay. In this way, we had to make the conditional table of this alarm with respect to this. Okay, that is the one thing. Now move to the next node. Now alarm. Alarm has two conditions. One is probability true. One is true. Oh, sorry. One is true and second is false. बच सकता है, नहीं बच सकता, दोनों में से एक चीज हो सकती है. ओके, ये अलार्म पे आ गए. नाउ प्रोबेबिलिटी ऑफ P1. Probability of P1. कि P listen that alarm, true. Probability P1 doesn't listen that alarm, false. Okay, that is the probability with respect to P1. P1 is any person like the Rahul and the Paras. Now here I will take any value like the 90 and 10 for probability. Similarly for here also 0.05 and any 9.5 values. Okay, that is with respect to the P1 call. Now let's move to the we are calling P1 with alarm. Now Let's move to another. If this is for the P1, now similarly we have to do it for the P2 also. Again, alarm contain two conditions, one true or false. Okay. And probability for P2 true, that is one thing. And the probability for P2 false, that is another thing. Okay. Now 0.70 and 0.30. We have taken the values. But remember this, the addition of both values should be 1. In this way, we had made the conditional table of this example. We had made the conditional table of this example. Now the question can become like this. Find that P1 and P2 call. Find that P1 and P2 call when ring the alarm and ring the alarm, but there is no burglary and earthquake. But there is no burglary and earthquake. You have to find the answer of this question with respect to this table. Yes, students, solve the question and answer. This question can be written like this also. Probability of P1 and P2 call means both are true. Call means both are true. When the alarm rang means alarm is also true. Next, neither burglary occur, neither nor earthquake. Yes, tell me now what will be the answer. The table is in front of you. You have to calculate that and you have to answer me. I will explain that. Question, I think question is clear to everyone. Means P1 and P2 call when the alarm ring, but there is no burglary and earthquake. Now, how we can solve this question? As all of you know, probability of P1 is with respect to P1 only call when alarm rang or not. Okay, there is only two situations. P1 call when alarm, yes, true rang. Okay, dot. Probability of P2 call when alarm ring, that is another probability because it is true. Next comes the third, probability of alarm. Alarm true, but there is no burglary and there is no earthquake. That is one thing. Now, individual of this, no burglary probability of and probability of no earthquake. Means we have to calculate the probability of the each. Now, P1 with respect to A. P1 with respect to A. P1, where is the table of P1? Here it is the table of P1. That is visible to everyone. Table is visible to everyone.
मैम थोड़ा zoom कर दो.
Zoom कर दूंगी ना अगर. I will write the statement again here, okay? Question is clear to everyone? First question is clear to everyone?
Yes, ma'am.
Yes. Now table is in front of you. I'm writing the equation again. Oh, sorry. I'm writing the equation again. Probability P1 calls, P2 calls, alarm ring, but there is no burglary and there is no earthquake. That is the question. To solve this probability, we can write like this. We have to calculate the probability of each. Probability of P1 with respect to alarm, as in the diagram you can see, probability of the P2 with respect to alarm, that is another. Now what about the probability of A? That no burglary and no earthquake, that is another thing. Now, and we have to also calculate the probability of each, no burglary and the probability no earthquake. Now you have to just take P1 true, alarm, P1 call, if alarm true, P1 call means this value, alarm true, P true, the value is 0.90. Now tell me what will be the next value? What will be the next value?
Ma'am,
P2.
0.70.
0.70. Yes. Now, next, probability of alarm, not burglary and not earthquake. Alarm, probability of alarm. Here it is a probability of alarm. Probability alarm means true, but no burglary and no earthquake. For both are false. What will be the answer?
0.001.
0.001. Okay, now next, probability of burglary. That is 0.00. That is not means false. Yes, tell me what will be the answer? What will be the answer here? I have taken the value for this, I have taken the value for this, I have taken the value for this. Now I am going to take the value for this. What will be that? What is the value here?
Ma'am,
Yes.
999.
Point.
I guess 0.999.
And in the case of the earthquake?
0.998.
0.998. Okay. In this way, you calculate. Now you only have to multiply it and you get the answer like this. This is the answer of this question regarding the Bayesian network. Okay, students, let's start with another topic of the machine learning, that is the Naive Bayes algorithm. Okay, Naive Bayes algorithm. Basically, all these algorithms are used for doing the predictions. As all of you know, ML totally works on the concept of the predictions and on the data only. So Naive Bayes algorithm is an algorithm that learns the probability of an object. Naive Bayes algorithm is an algorithm that learns the probability of an object with certain features belonging to a particular group. I repeat this line again. This algorithm is an algorithm. Okay, this is an algorithm that learns the probability of an object with certain features belonging to a particular group or a class. That is the Naive Bayes. Like, let's take an example. If I want to find the probability of the fruits in the bucket, like the one bucket contains the oranges and the mangoes, apples. Okay, and we have to find out how many bananas, how many oranges are there, how many mangoes are there, and how many apples are there, and what is the probability of each. I am telling you that this naive Bayes algorithm also work on the concept of the probability. This naive Bayes also works on the concept of the probability. Again, this also helps in doing the prediction. Helps in doing the prediction. Like the examples of whether we want to predict from the bucket how many oranges are there, how many mangoes, and how many apples are there. Okay. Now, whenever we want to work with this algorithm, we should know the one formula, that is probability. Again, it also deals with the concept of the probability. Probability of A with respect to B means probability of A if B is true. Now, this is a formula. Basically, I am writing probability of the B if A is true. Probability of A if probability of A only and the probability of the B only. This is the formula of the naive Bayes. When you want to work with the concept of the naive Bayes, you can apply this formula. That probability of the A if the B is true. Probability of the B if A is true. Probability of A and B. You can see just A and B. Reverse that, B and A. And A at the top, A at the top. B is the bottom, B at the bottom. That is the formula of the naive Bayes. Okay. Now, this is basically the formula of the naive Bayes. Now, let's take an example so that you can easily understand this algorithm. I'm going to make the one, as all of you know, ML need data, and data is always in the form of the CSV file. Okay, now I'm going to make, here I make one table. Okay. Basically, again, naive Bayes works on the 3 steps, works on basically 3 steps. One step is frequency table. One step is the frequency table. First step we make the frequency table. Second, we make the likelihood table. Likelihood table. First we make the frequency table, then we make the likelihood table, and then we apply above formula. Naive Bayes formula, that is this. Whenever I want to work with the concept of the naive Bayes, first I have to make the frequency table, then make the likelihood table, and then apply the above formula on that according to the required question. Whenever the machine want to do prediction, according to this question, machine apply the formula by taking the data from both tables and answer your question. Now here I am going to make the table that is called the frequency table. First step is, step 1 is to make the frequency table. First step is to make the frequency table. Now, let's take the one like there is one component, that is the weather, and second is the play. Okay. Here I'm taking some values like whether if sunny, and any player or any kid can play or not. No. If overcast, I'm just taking the entries Okay, I'm taking the data, making the CSV file. And this CSV file is called the frequency table in the case of naive Bayes. Overcast, yes, that is another value you can take. Like the rainy, yes. Sunny, these are the values, data set only I'm making in the form of the frequency table. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, after sunny, right? I'm writing the overcast. Yes. Rainy, no. Sunny, yes. Rainy, no. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Okay. Here I will write the value. Sunny, yes. Rainy, no. Overcast, yes. Sunny, yes. Rainy, yes. Okay. I'm going to okay, now this is a database, data set, or we can call data set, which is available in with us in the format of the CSV. Okay. Now, if we want to apply the naive Bayes, first we may have to make the frequency table. First, we have to make the frequency table. Okay. First, we have to make the frequency table. Now, here, this table is called the frequency table. Means, how many features are there? This is the one, weather. Okay. And play or not play. Now, play or not play. This is one. Now, in the case of weather, you can see how many features are there. There is one, sunny. Second is overcast. Third is rainy. Is there another any feature? Is there another feature? There are only. Is there any another feature in this table? I think there is only 3 features. One sunny, one overcast, and one rainy. So, while making the frequency table, means the frequency of the features. Overcast, rainy, and sunny. These are the 3 features which are available in this. Okay. First, we have written this. Now, in this case, there are only 2 things. Yes or no. So we have written it like this. Yes or no. Now you can see we have to check. Overcast, how many times? Yes. If overcast, player can play. 1 overcast, yes. 2 overcasts, yes. 3, yes. 4, yes. I think the value here is yes is 4. Okay. Now tell me what about the no in the case of overcast? Is there any value of the no? If overcast, kid will not play or the player will not play. Is there any probability by which is present, the data which is present in this table? Is there any probability? Yes, tell me. What should I write here? What should I write here?
0.
0. Yes, there is no probability. Now let's move to the next. Rainy. Now in the case of rainy, tell me what is the probability of yes? What is the value of the yes?
2.
2. And what about the no?
3.
3. And what about the sunny now? Yes. And first tell me yes. Yes.
3.
3. Okay. Sunny and yes. 3. Okay. And what about the no? What about no?
2.
2. Okay. And you can see the probability of no is 5 and probability of this is 9. In this way, we can able to make the frequency table from the large amount of the data. And this is the first step while working with the naive-Bayes algorithm. This is the first step while working with the naive-Bayes algorithm. In the exam, this data set will be provided to you and you have to make the frequency table, likelihood table and the question of and answer the question also. Okay. Frequency table. We are making the likelihood table. Second step is to make the likelihood table. Now for this, basically we are making these tables so that we can easily put the value in our formula. Likelihood table. This is frequency table. And likelihood, basically the table which is present with us. Okay. With that, this is our frequency table. I am first just copy that table. I write here whether no, yes, values are overcast, rainy and sunny. Okay. Here 0, 3, 2, 4, 2, 3. I'm just copying the value from here. Okay. 5 and 9. That is the total. Now likelihood table is basically to find the probability of each case. Means what is the probability of the overcast now? What is the probability of overcast? Anyone? What will be the probability of the overcast? What is the probability of overcast?
4.
4 and what we say? Probability always calculated with 4 with respect to total. What is the value of total is? 14. The value total is 14. In the case of from the 14 entries, there are the probability of overcast is 4 only. Yes, agree with me? In this way, we calculate probability. Na? The probability of the overcast is 4 from the 14 values. Yes? Agree with me or not?
Yes, ma'am.
Now you can calculate the answer here and divide that and you will obtain like the value this. Okay. Now tell me what will be the probability of rainy? Probability of rainy. Yes. What is the probability of rainy? Yes, probability of rainy. Any student tell me what is probability of rainy? Students, I am asking you, what is the probability of rainy?
Ma'am, 2/14.
2/14. Why 2/14, Manpreet? I am asking the probability of rainy. I am not asking the probability of 2 or yes.
5/14 होगा.
Yes, 5/14. Rainy entries are of 5. Some of the no and some and yes. But there is a probability of rainy. Each value. And what about the probability of sunny?
5/14.
That is 5/14. In this way, we can calculate the probability of the each. Now, tell me probability of no. What is the probability of no? I am calculating the probability of the each individuals. Now tell me what will be the probability of no?
5/14.
5/14. And what about the yes?
9/14.
9/14. This is called a likelihood table in which we are calculating the probability of the each feature. Here we are calculating the probability of each feature. Now question is, now till now any doubt or any question from your side? Now last step. Last step of this is, that will be the question. That will be the question. Like, player will play. Now, here we have to apply the Naive-Bayes formula. First, listen the question. Player will play if weather is sunny. If weather is sunny. Player will play if weather is sunny. Is this statement is correct? The question is, player will play if weather is sunny. Means if weather is sunny, player will play. Is this statement is correct? So to solve this, you have to apply the Naive-Bayes formula. You have to apply the Naive-Bayes formula. Naive-Bayes formula, that is, Naive-Bayes formula is A if it is given, and this is a likelihood, into B A, and here it is the B. This is the formula of Naive-Bayes. And now what is A and what is B in this case? Anyone? What is A and what is B in this case? What is given with us? What is given with us? Yes. Anyone? What is given with us?
Ma'am, probability of yes if sunny. तो A हो गया yes, B हो गया sunny.
Sunny. B हो गया? Sunny?
B हो गया ma'am.
वेदर गिवन है ना? B हो गया? Sunny?
A हो गया, player will play.
A हो गया yes.
Yes हो गया. Means we have to calculate like this. And here what should I write? Sunny? Yes. Here? Yes. And here?
Sunny.
Sunny. Okay. Now tell me what will be the answer of each? Yes, tell me now. थोड़ा सा erase कर लें so that you can easily understand. क्या erase करें? Let me wait, hold on. We have to calculate probability of sunny if the yes is given. Yes is total 9. From that 9, we have to find the 3. So here it is. So the answer will be 0.33. That will be the value. Now you have the values of PS also. You have the value of Sunny also. Let's put it in the formula. P Sunny. What is the value? Point. This is the value, I think. So that is the value. Next is P yes. Yes. What is the answer of yes?
0.64.
0.64. And Sunny, only Sunny. So only Sunny yes. ये Sunny था ना?
0.35.
ये हमने गलत लिखा है यहाँ पे. We have written here wrong. We have to write here Sunny with Sunny. 0.3. 0.3.
0.35.
35. Solve it and tell me what is the answer.
0.60.
0.6.
0.60. Okay. Now, as you know, if our probability comes above 0.5, then it is always yes. And if it is less than 5, then it is become no. So what is this statement is correct? Player will play if weather is sunny. Is
Yes.
this statement is correct?
Yes.
Yes, because we have the probability higher. If it is less than 50, then we say this statement is incorrect according to our data. If our answer comes less than 50, then we say the probability of above statement above statement is wrong. Above statement is incorrect. Okay.